Welcome back. This is section 9.4 on potential energy. This is section 8.4 in your textbook. There are three types of potential energy. Remember, potential energy is energy due to position. So position of what? There's three kinds. You have elastic potential energy. So if something is elastic or something has a spring quality, then if you distort that spring property, there is a restorative force that wants to pull it back. So if you, for instance, compress a spring and let it go, that spring will snap back to where it wants to be before. If you pull a spring, it will want to stretch back to where it was before. So a rubber band, any type of elastic qualities like that would be energy. So if you pull something back further than it wants to go and you do not break it, you can have a restorative force. So the bowstring on a bow and arrow, it is being pulled back tauter than you would want, and so it will restore itself to a natural equilibrium. And it has energy stored in it. Chemical energy, if you separate ions so that they want to go back together, positives and negative charged particles that want to attract to each other, because there is a force of attraction between charged particles. If you separate them and give them a path, that's how electricity works. That's how anything that's electric would work, is by a potential energy that's chemical. Then gravitational potential energy is lifting something in a gravity field. So generically, potential energy is energy due to position, or it's a stored form of energy. So work has been done on an object and stored energy by virtue of doing work. So you put work into something, you now have potential energy, and that potential energy now has the ability to do work. If you remember from last section, energy is the ability to do work. So potential energy is stored energy that can then be used to do work. So we'll quickly go through some of these examples. Elastic potential energy, if something is stretched or compressed, it's going to want to restore, and when it restores, it can do work as it's restoring. So the stretched string on a bow can pull an arrow with it as it's being restored. A compressed spring, if you put a little plastic junky toy on it, can pop out like a jack-in-the-box as a result of its being restored to where it belongs. Chemical energy normally is in the form of ions. So if you have a positive and a negative particle and you separate them, they're going to want to restore. Also, if you have an electron, which is a charged subatomic particle, and you give it a source of positives, that electron can move, and that's how electricity works. So electricity works on stored energy. So if you have, say, a battery is going to be chemical stored energy. Also, food is chemical stored energy. If you eat food, your body has the ability to break that apart and release the energy that's in it. So if I were to take a tablespoon of sugar and burn it and actually have a fire, the same amount of heat that comes out of that burning sugar is the same amount of energy that your body can extract from that sugar at room temperature, at body temperature. The form of potential energy that most people are familiar with is gravitational. So if you lift something up in a gravity field, say we're on the Earth, we're in a gravity field, and I lift an object up and then drop it, the gravity of the Earth's pull on that object will move it. And then that movement can create work. So water can go over a water wheel because the water is higher up than it was. So as it's flowing down a stream, it can make a wheel move. That wheel can then grind corn or generate electricity or whatever. Water stored behind a dam can go through a hydroelectric plant, and as it's falling, it turns a turbine and makes electricity, etc. Okay, I've already said that potential energy is the same as the work that's been put into something, and work is going to be a force exerted times a distance. Well, if you are lifting something in a gravity field, that distance is your height. That's how far that you've lifted it. And your force is newtons, and newtons is going to be your mass, okay, times your acceleration, F equals ma. So your acceleration of gravity is g. So your weight is your mass times gravity. That's your Newton weight times your height. So your potential energy is going to be mgh, your mass times acceleration of gravity, 9.81, times whatever height in meters that you've lifted in. So this is important. That's your first formula for this section. This is an important point. Potential energy it does not matter how that potential energy was acquired. So for instance, if you have a 200 joule energy, a potential energy, a boulder that has 200 joules of potential energy, you've got 2 meters high cliff. Okay, so that's 100 Newton boulder. So 100 newtons times 2 meters is 200 Newton meters, which is 200 joules. It doesn't matter that it was lifted straight up onto the cliff. It doesn't matter if it was put up on the cliff by a ramp that was 4 meters long, or it doesn't matter if it was hoisted up steps. It doesn't matter if it went up on a helicopter and then was lowered down on the cliff. It doesn't matter if it was abducted by aliens and taken to another planet and then put on the cliff. Whatever it is simply going to be how heavy it is. So 100 newtons. So this is 100 newtons. And 2 meters from the ground. That's how much potential energy it has. So the path doesn't matter at all. Okay, let's see if you've learned something. You lift a 100 Newton boulder 1 meter. So what work is being done? So work, remember, is force times distance. So the force is 100 newtons. You have to remember that weight is actually a force. It's the force you're putting down on the floor. So you have 100 newtons times 1 meter. So that is 100 Newton meters. And a Newton meter is a joule. So the work done is 100 joules. That's A. B says, what power is expended if you lift the boulder in a time of 2 seconds? Well, if I have 100 joules and it takes me 2 seconds to lift it, okay, the wattage, which is my power, equals 50 watts. I'll put watts there. 50 watts of power. What's the gravitational potential energy of the boulder in the lifted position? Well, how much work has been done on it? 100 joules of work. That's how much energy it's got. So I put 100 joules of work into an object. It now has energy because it now can do work. If that boulder could fall on something, it could make something happen. Okay, if it was water, it could make something happen. If it was a hydroelectric plant, that water could now move a turbine. And so if you put work in something to make it have more energy, you've given it the same amount of energy that you put work into it. So this is B. C is going to be 100 joules of energy. So you have 100 joules of work. And if you do 100 joules of work on something, you've got 100 joules of energy, specific potential energy. Okay, review. Name 3 examples of potential energy. Well, the one most people remember is gravitational potential energy. You also have chemical potential energy. That would be like a battery. And then you have elastic potential energy, which would be like a bow and arrow, where that bow is pulled back and the arrow is about to spring from that. Okay? Good.